Hi, this is Team 82's 5-minute video of the final project symposium presentation for the 2024 Spring ECE 542 Neural Networks course. Our project title is a fine-tuned Llama 2 model for reasoning and action. The team members are Sudhanshu Goswami, who's our main architect and lead programmer working on a GTX 4090 GPU machine that he built. Me, Ramesh Lakshminathan on my M3 MacBook Pro, and Swarit Bidwalkar running on Google Colab on his Windows laptop. Now, large language models like Llama or GPT generally perform well on standard prompt response or standard question and answer tasks, but do very poorly when the task calls for a certain amount of reasoning or use of extended or external new information. So our goal in this project is to fine-tune a version of Llama 27B, that's a 7 billion parameter model for React. This is called reasoning plus action using a form of advanced prompt engineering based on a research paper produced by Shunyu Yao and his colleagues at Google Research. This image from the Yao et al. Paper shows the basic structure of the advanced prompt engineering technique. So 1A is your standard question that gets a response. 1B introduces a little bit of reasoning through a method called chain of thought. 1C actually gets the system to take an action like an external tool, and 1D, which is reasoning plus action, puts it all together and uses the external tool to search Wikipedia and help generate the correct answer. The external tools could be Wikipedia search, it could also be a calculator, for example, to do some math, or run a piece of code like a code interpreter and generate an answer. So to summarize the prompt method, engineering method, you start with the question and the system is directed to generate a thought, and that thought generates an action, which could be to go search Wikipedia. The result of that is an observation or evaluation of the search results, which could lead to another thought. And this could cycle a number of times until a finish criterion is reached and the action is generated that says finish and provides which at that point it thinks is the correct answer. Now, the Google research paper work on React prompt engineering was primarily done on proprietary large language models. Our project is an attempt to actually replicate that process on an open source large language model, in particular Llama 2 7B. And in order to do so, we used a React Llama database and the Hugging Face libraries, which has been used by others to attempt to do the same thing. This database has 3,538 correct React trajectories, which is a question with a trajectory of thoughts, actions, observations, and finally the correct answer. And this is what we intend to use to fine-tune the Llama model. So here's an example of the thought action trajectory. The question is, which one, Bogazici University or Basilica Cistern, was built in the 6th century during the reign of Byzantine Emperor Justinian? So it goes through these various thoughts, actions, searching Wikipedia, evaluating the results, and finally comes up with the correct answer, which is Basilica Cistern. One of the first things we realized was that Llama requires a very specific format for its prompts, and that we needed to include special tokens, for example, start tokens, end tokens for each of the action pairs, instruction begin, instruction end tokens, and so we had to go through and reformat all the data. Now, before we look at the fine-tuning itself, here's a quick review of the transformer architecture in comparison to Llama. On the left is the transformer architecture based on the famous Attention is All You Need paper that launched the whole revolution in AI. And on the right is the architecture of the Llama model. Llama is called a transformer model, but it's pre-trained and only has the decoder section, not the encoder section of the architecture that was described in class by Professor Lobaton. It also uses a special activation function. Instead of ReLU, it uses SWIGLU, which is a slightly modified function that has a smoother performance response. Also adds an RMS norm layer and uses something called ROPE, or rotary position encoding, as opposed to the traditional positional encoding in the original transformer paper. There are various methods for generating tokens or actually providing responses to the queries used in large language models, and we used a number of these. Discrete methods like greedy search or beam search, stochastic sampling methods like TOP-K or TOP-P, also called nuclear sampling, and a modern method called contrastive search that incorporates the best of some of these. Now, the pre-trained base Llama model would hallucinate and in some cases proceed to ask its own questions in response to the question that we asked. So we used the Llama 2 7B chat model, which is not only pre-trained but also fine-tuned for chat and was able to give us better answers. In the fine-tuning, it was actually able to respond properly to chain of thought prompting. And as you can see, it was able to answer the question in a very reasonable sounding way. Of course, it so happens, if you look at it carefully, that the math in this answer is actually wrong. This is just a little fun slide to show you that most of our work was spent in fixing errors and wrangling with libraries. Finally, we were able to get the Llama model to provide us with some correct answers. And here's a couple of examples. This is obviously just one step along the way to get this project actually completed. But it's actually able to reason carefully. And if you look at the questions, one has to do with the elevation of a particular part of Colorado, and the other one has to do with a particular Simpsons character and who it was named after, and both have worked very well. Yao and his colleagues at Google Research have recently released a new paper which goes beyond React to reflection plus React, which actually has to do with going through a sequence of thought action cycles, and after say 5 rounds of thoughts and actions, actually reviewing the overall strategy. So it's actually called reflection plus React. This is a recursive approach to prompt engineering inside prompt engineering. Also, 2 days ago, Meta released Llama 3, which we anticipate will perform better at reasoning tasks. Here are our main references, all available on request. And finally, thank you for listening, and we are available for any questions.